Mary can cycle a speed of 25 in a time of 1 hour and 12 minutes, and we need the distance from A to B to find the full distance of the course. According to Dad's silly triangle, distance is speed by time, but I've got one unit in kilometers per hour and another one in hours and minutes. I'm going to turn them both to hours, so I need to change the hours to hours and minutes. It takes Mary 1.2 hours to do that part of the course, as 12 minutes is 12 out of 60. 25 distance equals speed by time. 25 by 1.2 will give us 30 kilometers. And by adding all the sides, we get a distance of 62 kilometers. It takes Mary 4.8 hours to complete the course. We already know that the cycle took 1.2 hours, so let's find the remaining time. Remaining time is 3.6 hours. We know the time for swim plus the time for the run must therefore be 3.6 hours. According to Dad's silly triangle, I can calculate time by doing distance divided by speed. I know the swim is the slowest, so I'll call that x. I know the run speed is 5.6 times faster, so that would be 5.6x. I know the distance for the swim is 4 kilometers, so time is distance divided by speed, 4 over x. I know the distance for the run is 28 kilometers, so the time, distance divided by speed, is 28 divided by 5.6x. When I add them both together, I get 3.6 kilometers. I get a common denominator for both of 5.6x, and then bring the 5.6x over to multiply. 50.4 equals 20.16x. So finally I get x, which represents the swim speed of 2.5 kilometers per hour. I need to show the angle ACB is 116.5. C is the center number. This is the angle they're talking about. It's not a right angle triangle, so it's sine rule or cosine rule, and cosine rule is the only one we can use here. Remember with cosine rule that whatever side you start with, you must have the corresponding angle at the end. Seeing as this is the angle we want, we must begin with this side here. Filling into the formula, rearranging and solving, we do indeed get an angle A of 116.5 degrees. Apply the regulations. The region inside the triangle, of course, must be kept clear. Find the area of this region. We have a formula for the area of a triangle, a half AB sine C. This formula requires any two sides of the triangle, but must include the angle that links both of them. This gives you an angle of 50.1 kilometers squared. The shortest distance from C to AB. Shortest distance from a point to a line is a line that is at right angles. If you wished, you could now refer to this as the base of the triangle, and this is the perpendicular height. We can use those two values to find area, and we already know the area is 50.1 kilometers squared. That gives that length h there, 3.3 kilometers. Next question, I'm asked to find the point AT. I'm told that tower is vertical, so I've drawn in my red line, and you notice that there's a right angle there. I've redrawn this in 2 dimensions here, and they want us to find AT. So simply using a right angle triangle rules of SOHCAHTOA. Because we're using the angle at B, the side opposite that is marked the opposite. Then we have the hypotenuse, which is the longest side, opposite 90 degrees. The remaining side is the adjacent. I'm looking for opposite. I have adjacent. The only one with O and A is tan. The angle is opposite over adjacent. The opposite is AT. The adjacent is 30. You get a value of 0.026 kilometers, which is 26 meters.